And the amount of flour per vanilla cake is 200. And the amount of flour per chocolate cake was 100 grams. So 5,000 has to be greater than or equal to 200x plus 100y. Because again, I cannot exceed 5,000 grams of flour. That's all I have on hand. Okay. Next, there's a constraint for fat. I have 1 kilogram of fat on hand. If I convert that to grams, that means I have 1,000 grams of fat on hand. And a vanilla cake requires 25 grams of fat, and a chocolate cake requires 50 grams of fat. And so this is my other inequality. So these are my constraints. Okay. So we have our objective function, we have our constraints. Let's graph the constraints and find the corner points. Again, I have these two as usual. So I'm in the first quadrant, so that's all I'm going to graph. We can kind of zoom in on that. And now I'll sort of write down the equations again, but I'm not going to hardcore solve these out just like last time. Seems like once, yeah, the markers don't last very long. Sort of discouraging. Anyway. So for the flour inequality, this 5,000 greater than or equal to 200x plus 100y. I could solve this out. And I believe what we'll get, if I were to rewrite it as an equation and solve it for y, the equation we should get is y equals, shorten that guy, y equals negative 2x plus 50. Subtract 200x from both sides, divide both sides by 100. I believe this is what you should get, if I haven't made any mistakes. Negative 2x plus 50. So that means I'm going to be looking at a y-intercept of 50, which is kind of big. So again, this will be a situation where maybe it's useful to use different units on the axes so I don't draw every single tick mark. So maybe I'll count by tens. So 10, 20, 30, 40, 50. It'd be good to count by tens. I'll count by tens over here too. So 10, 20, 30, etc. So we'll count by tens just to make it so that I can actually graph this reasonably. And then every time I go to the right by 2, I have to go down. I should graph this in red, I suppose. Every time I graph this, every time I go to the right by 2, I go down. Sorry, every time I go to the right by 1, I go down by 2, is what I should say. So go to the right by 1, down by 2. Something like this. Pretend that was straight and through the lines. So something like this red line here. And then next, we'll put this guy in, I guess in purple, even though it's not really cooperating. Kind of frustrating. Anyway, if I were to write this as an equation and solve it out, the equation would be the following. Y equals negative 1/2 x plus 20. And so again, I'll kind of leave it to you guys to solve these out and get the equations. I trust you guys can do that. If you have troubles, just let me know. So I have a slope, y-intercept of 20, and I have a slope of negative 1/2. So when I go to the right by 2, I go down by 1. Something like this. Okay. And now what we would need to check is where to shade. Again, by testing points, we could figure out where to shade in relation to the red and the purple. It turns out I'm going to shade underneath both lines again. So I'm going to shade underneath the red and underneath the purple, which means, given that I'm also shading to the right of the y-axis and above the x-axis, I'm shading in this region down here. So my feasible set is this region here. Staying underneath both the purple and the red, and above the x-axis and to the right of the y-axis. This is my region. So there's our feasible set. Okay. So now we just have to look for corner points. I have one here, I have one here, I have one here, and I have one here. This looks a lot like the last problem. Maybe it's scaled differently, but it's a similar kind of shape to the last problem. Anyway, which of these corner points are sort of obvious? There's maybe only 2 of these that are really obvious. The ones on the y-axis. So, I know 0, 0. I know 0, 20. But what about these two? So we'll take this one on the x-axis first. This guy is the intersection of the red line with the x-axis. So I'm taking y equals 0, and then the equation for the red line, which is y equals negative 2x plus 50. So we're going to solve this for x. So plug in y equals 0. I get 0 equals negative 2x plus 50. Subtract 50 from both sides. Divide both sides by negative 2. I think we're getting x equals 25. Is what it looks like to me. X equals 25. So I don't know. If we go back and look, it does look like this point is kind of halfway between 20 and 30. But maybe it wasn't exactly halfway. So it's good that we checked just to make sure. But 25 is halfway between 20 and 30. So that sort of makes sense with the picture I drew. So maybe this time I actually drew it kind of good, kind of well. But anyway, it's always good to check to make sure if we're not 100% confident, which I never am. So this point had coordinates 25 and 0. Okay. So that leaves one more point. That leaves this point here. What are the coordinates of this point? Let's find out. That's the intersection of the red and the purple. So I take the equations from the red and the purple lines. Red line had y equals negative 2x plus 50. The purple line had y equals negative 1/2 x plus 20. And now I need to solve this system. And I'm going to do that by, again, substitution. I should make that 50 look. Oh my goodness. I tried to fix it. Made it worse. There we go. We're going to solve this system. I'm going to substitute y equals negative 2x plus 50 into the second equation for y. So I'll get negative 2x plus 50 equals negative 1/2 x plus 20. And now I solve for x. Maybe I'll multiply both sides by negative 2 to kill this negative 1/2. So multiply both sides by negative 2, I will get 4x minus 100 equals x minus 40. And now I'm going to subtract x from both sides. I'm going to add 100 to both sides. And I think what we're finding is that x is 20. If I divide both sides by 3, I should get x is 20. So x is 20. How do I find y? Well, I just plug x back into one of these equations. If I plug 20 for x, that's y equals negative 2 times 20 is negative 40, plus 50 is 10. So it looks like y is 10. Y is 10. So the coordinates of this point are 20 and 10. Okay. So this is good. We now found all the corner points. So now that we've done that, the last thing to do is to find the maximum number of cakes that we're going to be able to make, which means we need to find the maximum of the objective function. And so to do that, we just plug in our corner points and see what we get. Find out where the biggest number occurs. So I'll make my little table. So on the left, we put our corner points. I have 0, 20, 0, 0, 25, 0, and 20 and 10. And so I just need to find the maximum value of p out of these. So we just plug these into p. P is just x plus y. So 0, 20 just gives me 0 plus 20. That's 20. 0 plus 0 is 0. 25 plus 0 is 25. And 20 plus 10 is 30. So just think about what these numbers mean. Of course, if I produce 20 chocolate cakes but no vanilla cakes, I'm going to have 20 cakes. If I don't produce any cake, I have no cakes. If I produce 25 vanillas and no chocolates, I have 25 vanillas. And if I produce 20 vanillas and 10 chocolates, then I have 30 total. Because again, our function is just adding the two amounts up together. But anyway, what do we see? We see that our maximum is 30. This guy's really dying on me. Our maximum is 30, and so there's our answer. The maximum number of cakes that I can produce, given those constraints, is 30 total cakes, where I have to produce 20 of them vanilla and 10 chocolate. There's our answer. Okay. So maybe a sort of open-ended question that you guys might want to think about is, this graph looked basically like the other graph or the other problem. And in both cases, the maximum occurred at this weird point here where these two lines intersected. So you should think about, And when I say should think about it, I mean, you know, if you want to think about this. If my graph looks like this, do I always get the maximum at this weird point here? I don't know. You should think about that if that's true or not. If you think about questions like that, then you're really doing math. Otherwise, I'm just saying things at you. Anyway, let's leave that at that. Do you guys have any questions for me? Okay, so sounds like the answer is no. So that's, I don't want to do any more examples, I think, today on the board. So I'm going to leave it at that. So the rest of class today, which is 20 minutes, I'll leave for you guys to look at your activity 7.3. And if you have questions, I will, you know, we'll be here to answer questions. And just as a note, tomorrow in class we'll review for the exam. So I posted a review sheet on Canvas earlier today. So later on, you should take a look at that. And tomorrow I can go over problems from that and answer any questions. But anyway, let's take the rest of the time of the day for the activity, and you guys can ask questions if you have them.